Alright guys, welcome back. So we are dealing with a new problem, slightly different from the three we worked with last time. So this is our fourth episode of the series, and today we're given an array nums, and this array is of size n, and we want to return the majority element. This is an easy problem. The majority element is the element that appears more than n divided by 2 times. Okay? So we assume that the majority element exists, which is absolutely not always true. So for example, here the majority element is 3, and here the majority element is, well, we have that the array is of length 7, and so the output is 2 because 2 repeats itself 4 times. We want to solve the problem in linear time and O1 space, but still, let's try first to arrive at the first solution, and then we go to the calculation of the complexity, and let's try to solve it in the easiest way possible. So let's see. So something that we can do is to create, I was thinking maybe we can create a dictionary. So for each value in the input, we can increase by 1 the number of times it repeats. I don't know if this is the best approach. Okay, I don't know if this is the best approach. Let's avoid the use of a dictionary. Let's use a list. So we may initialize a list composed, let's say that we want to initialize a list called count, and we want to initialize it as an empty list of with n elements. So basically what we do is to say 0 times n. Okay, we don't have n though, so we can just define it as the len of our nums. And then what we can do is for a number, for num in nums, we can just say that we increase count associated with, so if I do count.index num, it will give me the, no, I can just say, let's say, count num. So I'm extracting the count, the num, like the element in the list associated with num, and then I'm adding 1. And this should work, because then I can just say that what do I want? Do I want to majority element? So let's say majority element is equal to the maximum in count. I don't actually know if I can do that with a list, but let's try. Let's see what happens. There's an index error, list index out of range. Oh yeah, that's absolutely true, because the point is it is not necessarily true that a list is composed of numbers, like the list goes from 1 to n. It may be much bigger, and this completely invalidates my idea though. Oh no, this is not good. Yeah guys, I really think we should go on with the dictionary then. So let's try to change completely our strategy from here. Okay guys, so let's create a dictionary, and then we try to do the same thing we did before. So for num in nums, and then we just say, all right, so we want, so in this dictionary, the idea is we use the numbers as keys, and as values we use the counts. Okay, so we want the number num, and if num is not defined in the dictionary, we take the value 0, of course. So we have this string counts get num 0, and then we want this to increase by 1, and yeah, that's it. And we at this point want to get the maximum. I don't think though that this is the right syntax. I think because here we have the counts, and then we want the counts of num to be equal to this, right? Yeah. And then, of course, we want that if counts num is greater than n divided by 2, well, it's a ceiling function. Yeah, but this doesn't matter. Sorry, this is a floor function though. Yeah, then we want to return num. Yeah, this should work, guys. Yeah. This time, sorry guys, because I wasn't very clear during the explanation. This is not good. So let me explain again, which is my reasoning behind this problem. So we define n as the length of the numbers, and then we define a dictionary, which in principle contains values like the value 3 is repeated 1 times, the value 2 is repeated 2 times, the value 4 is repeated 3 times, or 4 times, okay? So in this case, the majority element is 4, and each time we just add the count for each element of 1, and then if count is greater than n divided by 2, we return num. So let's try to submit this solution. The solution works as expected, but we have a problem. So the problem is we want to solve the problem in linear time, so O to the n and O1 space. Yeah, I think guys, actually this is On in number of iteration. The problem is in terms of the space. Here we want O1. Well, here in the worst case scenario, we have O to the n because we are defining n elements. And this is not what we want. Okay, so guys, basically I see that what we can do here is we can just avoid using a dictionary, because this is the problem, literally. Like, to avoid any space trouble, we need to define just a count variable and then nothing more. Well, the for loop is okay. The for loop is okay. But how do we use just one value? How do we use just one value? Alright guys, so I'll be completely honest, I had no clue on how to solve this problem. So in O1 space, so I just looked for the solution. I don't know actually how much time I should spend on each problem before looking for the solution. Maybe this is an information I should look at. But still, I had no clue, so I found that this is the best solution. It's a well-known algorithm. Let me explain this to you. So, and this should be an easy problem, guys, but this one that we did last time was much easier, in my opinion. It was medium. Don't know what this means. Okay, anyway, so the idea is the following. The intuition behind this kind of algorithm is basically that once you have that a number is repeating itself more than half of the time, this implies that the count, like that if you just count the number of times this candidate appears, it should be higher than the number of times this, or at least is equal to the number of times this does not appear. So basically, the idea behind this problem is if you just count like the number of times it appears and the number of times it does not appear, in the end, you should find that the value with the count that is equal or bigger than 1 is equal to the candidate, which is to the majority value. Okay? So let me give you an explanation for that. As you can see, it works. So suppose, for example, that we're dealing with this array 2, 2, 1, 1, 2, 2. Okay, just to give you a rough idea of how this works. Okay, so the count is initialized to 0 and the candidate is equal to none. Now, for each element in nums, we just iterate. Now, the count is 0, so now our candidate will be 2, right? So if our number is the candidate, which is true, our count goes to 1. So after the first iteration, the count goes to 1. And the candidate is 2. Now we go to the second element, which is 2. So the count will be 2, and the candidate will be still 2. Now we go to 1, so the count will be minus 1. So it will be in the end 1, again 1. So the count will be 0. And since the count now is 0, the next time, the third time, the count will be 0. So the new candidate will be number 1. You see? So now the candidate will be number 1 and it will have count 1. But the iteration after this, the count will go back to 0 as 2 repeats itself. And then during the last iteration, our candidate will be 2. And yes, the count will be 1, and we will return the majority element. And the reason why this works always is because 2 is repeating itself more or equal to n divided by 2 times. So this makes impossible the fact that we will return a different candidate. Let's try, just to give you an example, with 3, 2, 3, right? So we start with 3. So for num in nums, we start with 3, the count becomes 1, and the candidate is 3. Then with 2, the candidate is still 3, but the count shifts to 0. And then when we go to 3, the count is 0, but we reinitialize the candidate to 3. So in the end, we return 3, which is the right solution. So guys, not good this time because we didn't solve the problem. I actually studied this solution. We'll try to do better next time. But thank you very much for watching this video and see you next time, guys.